Okay, we're going to resume this video, and we'd already talked about the fact that these things were out of phase somewhat, and that's why we get, if we add up the two voltages, we get 140. I actually drop back a slide. So let's go here now. So the formula for applied voltage is this formula here for ZT. Is a derivative of that. We have to take the applied the voltage across the resistor, square it, the voltage across the capacitor, square it, add those, get the square root of that, and then we get the 100 volts. So you see that same formula kind of applies. So it'd be good for you to have these formulas written down, because obviously you're going to be needing those, and you're going to need to understand what you have and what you don't have to make this stuff happen. So once we know that, it's not going to be so hard. So we're going to solve for total current and voltage drops from this guy. Now, through his curveball, 2 resistors, 2 capacitors. And I don't know if this one's going to take us through. Yes, it is. So we'll kind of start and work with it. We don't want to work with it and then have to go through the same material. So it's given us an X of C1 and an X of C2. Remember, we get that by applying this formula. Now, I'm not going to write it down. Obviously, you can do that. But I am going to actually run those calculations. And I am going to make sure I'm using base units. So for both of these, there'll be 5 zeros, then the 1.3 or the 2.6, depending on which one. So we're going to start with C1. So we're going to say 2 times 3.14 times frequency, which is 60, times, and we're doing it for C1, which is the 1.3. Whoops, see, I already messed up. So let's do it again. 2 times 3.14 times 60 times 0.12345 zeros 13. And that is 1.3 microfarads converted to simply farads, equals, reciprocate that, and we come out with 2041, which if we move that decimal place, 1, 2, 3, we come out with 2.04K. Same thing is true here with the 2.6. We have to say 2 times 3.14 times 60 times 0.00345, and then C2 is 26, equals, reciprocate that, we get 1020 ohms, but if we move that decimal point 3 places, 1.02K ohms. So we're good there. So we see that math, we see how they applied the X of C formula to get the X of C for both C1 and C2. Now we're going to get total. That's simple. Add them together. That works just like it does with resistance. So our total is going to be the same way. We're going to add 1K and 2K. And we're going to get, no surprise there, 3K. Now remember, the Z total is a different formula. It's fixing to show us that. We've got to square the 3K. And then we've got to square the X sub C total. And then we've got to get the square root of that. So let's do that. RT was 3K, right? Yep. So 3 times 3 is 9. So our total squared is 9. Now we got to do X of C. So let's do it. 9's easy to remember, so I'm going to clear the calculator. So I'm going to take X of CT, which is 3.06, and we're going to square it. I can hit the square button. Then we can add 9 equals, and that's 18.36. So we got the 9 and the 9.36. We added them together, and we're going to get the square root of that, which is going to give us 4.28 as our ZT. IT, just like Ohm's law, we're going to take 120 volts and we're going to divide it by 4.28K, which is our ZT, and we're going to get a total of 28 milliamps effectively running through this circuit. At this point, we're going to take and find the voltage drops of each one of these. And if it's a resistor, it's just a matter of applying Ohm's law. If it's a capacitor, we've got to make sure we're using the X sub C of that. So let's look at each one of those. For ER1, it's a resistor, 28 milliamps times 1K, 28.03 volts. ER2 is a 2K, 28.03 milliamps times 2K, 56. Now we see those two. So for C1, we'll have the same current, but we've got to use the X of C1, which is 2.04K. We see it up here. Do the X of C2 for EC2. Multiply the current times that, and we get 57 and 28.59. Obviously, we add all these up, way more than 120 volts. But we can take this formula. We can add the two ERs, we can add the two ECs, and we can get the square root. So R1 is 28.03 plus 56.06 equals 84.09. So all they did to get this R value here is add up the ER1 plus the ER2. Same thing with EC1 and EC2. 57.18 plus 28.59 equals 85.77. We're going to square both of those. I'll go ahead and square this one, and it gives us this value here. I'll go back and plug in 84.09 and square it. It gives us this value here. Add those two up, we get 14,427. So I'll add 7356.49. We'll get the square root of that, and voila, not very far off, 0.11 volt off for the overall. So pretty much ballpark right there, well more than ballpark, almost dead on for a lot of rounding in each one of those. So, and again, that's all this is telling you. We're going to get some slight variances. If we carried this out to 8, 10, 12 digits, we'd be almost dead on the money. So now we get to do one on our own. So get ready to strain your brain a little bit. I really would like for you to pause the video, calculate this out yourself, and then see if you're coming up with the same things. But I'm going to work it out for you. See if you come up with the same things that I do, and then you can restart the video and get your answers. Okay, let's kind of resume here. We've got a couple options with this, but this is one that's going to carry us through virtually everything we've learned about. We're going to need total capacitance, or in this case, since we're doing voltage drops of each one, we're going to ultimately need the capacitive reactance of each of these. So, might as well just do it that way and then add that total up to get the total X of C. So, let's begin with that. So, we know that formula is, and I'll write it down for us just to have it as a reference, but I'm not going to write down every single action we take here just because of time and trying to keep the videos within a set amount of time for us to get through them. But anyway, let's get it started. So just remember that formula is 1 over 2 times pi times frequency times capacitance. So we're going to get that for each one of these. So I'm going to go ahead and put us in some blanks. We'll move the do that, move the calculator over, because I'm really worried about trying to get through this in the rest of our video, but if not, we'll have to start over. Let's come over here and let's put in X of C1, X of C2, and X of C3. So X of C1, X of C2, and X of C3. And I'll put equals, I'm just going to put a dash, and then X of C total will just be all of those added together. So we've got the formula right there, 1 over 2 pi fc. So let's take each one, and I want to keep the calculator where you can see it. So there, that's kind of centered. So we'll say 2 pi is 6.28. So I'm going to shortcut that and just say 6.28 times 100 is our frequency, times, and C1's value is 3 microfarads. So that's 0.00003. And hit equals, and then we're going to invert that. So X of C1 is 530 ohms. So we're going to write that down right here. So 530 ohms. Really, if we round up, it'll be 531. So let's make that distinction while we're thinking about it. Not going to make a big difference in the grand scheme, but might as well do proper rounding if we're going to do it. So let's go back and do X of C2. And we'll clear the calculator. And we're going to say 2 pi, 6.28, times 100, which is our frequency, times 0.00005, C2 being 6, equals, invert that, and we got 265 ohms there. So we'll write that here. 65, and we won't round since that's 0.39. Do the same thing for the last one here. And we're going to say 2 times 3.14. I could have done 6.28 times 100 times 0.12345, and then C3 is 2. Reciprocate that, 796 if we don't round ohms. So let's put that here. So 796 ohms. So that works out. We can add those together to get our total, because we'll need that in a moment. So 796 plus 265 plus 531 equals 1592. And I did that the other way while we were offline, and that's the exact thing I came up with, and I decided it would be better if we did X of C's of each individual one, so it works no matter which way you go. So 1592 ohms. So there's that, and we're going to need to do our next step. I'm getting rid of this other stuff here. The very next thing we need to do is get our total resistance. Well, that's easy, sports fans. RT is 1K. There's only one resistance. It is a 1K. RT equals 1K ohm. So that's really 1,000 ohms, and we need to bear that in mind because I don't want to mix my Ks with my units. I can make this 1.592K and this 1K, or I can do 1,000 and 1592, which is probably better. Probably going to be able to do one more step, and that's getting total impedance. And remember, that is ZT is equal to the square root of RT squared plus X of CT squared. So let's make that X of CT squared. So sorry for the little bit of confusion there. But basically, we got to square the 1592, add it to the square of the 1,000, and get our square root. And we're probably going to have to end the video on that. So I'm going to do that very quickly for us so we can end the video. So we're running out of time. 1592 squared plus 1,000 squared equals, and we'll get the square root of that. And I did them in the opposite order, but it doesn't matter because addition allows us to do that. So we came up with a ZT of 1,880 ohms. And I'm going to write that down quickly in this video, and we'll go into the next one. So 1,880 ohms. And we stopped at ZT, and we'll continue from there. So let me stop this video, and we'll